Yes, Mr. Ahmad, you can start now.
Okay. Inshallah, today we will make a demonstration for this heat exchanger, which is the AJS type TEMA heat exchanger. After receiving your drawings for this heat exchanger, our technical team prepare the 3D model for this heat exchanger, and we can check the inside components for this one, like the tube bundle. Let's open this tube bundle, and we will create it from scratch, inshallah, in this demonstration to know the steps of using SEG software and how we can create elements and tube pattern arrangement. Here we have this tube bundle, and if we take a section here in this channel, you can figure that we have this pass partition locations, and if we take a section in the longitudinal direction, we can figure that the arrangement of baffles, okay, and tubes, tie rods, like that. Okay, now let's start creating a new project. We will create this project from scratch, inshallah, in this demonstration. But before starting, let me ask you how much time you will take to make those drawings by the traditional way, by using the AutoCAD, and how much time you will take to make a 3D model if you are using Autodesk Inventor as a pure CAD software.
Yeah, normally we used to take 3.5 to 4 days to prepare the drawing in AutoCAD. And once again, then after checking, if some comments or anything is there, then 5th day we will do. So you can consider 4 to 5 days.
Okay. Let's start our demonstration of today, inshallah. Let's define the location of the project, here the project name. Now let's select the module that we would like to generate, which is the heat exchanger module. This module will give you the ability to create a tube sheet and tube pattern arrangement. From here, we will select Finish to start generating the project files. Now from the SEG tree, you will find the two nodes on this tree. The first node is the project node. From this node, you will define the project information like project number, client, location, manufacturer, all of that. And from here, for the equipment level, we will name or make a rename for this equipment as heat exchanger AJS type. Okay, and from here you can define the design data for this heat exchanger for the shell side and the tube side. And if you would like to modify or edit, you can do that easily. And you can check this area on other recorded videos on our channel to figure out how you can deal with the design data. But now we will focusing on the modeling and the detailing of this exchanger. From here, we will select the equipment setting, and from the equipment setting, we will define the position of the equipment, which is a horizontal position. And from here, let's select the direction of the assembly from right to left direction. Yes.
If this values is taken directly from the pivot, or
you can enter it manually. You will enter it manually. We, as discussed before, the BVLit exported access file not include information for the heat exchanger data. Okay. So we cannot deal with BVLit because no information on the access database file, as mentioned before. Okay, here from the setting, we will of the equipment, we will start selecting the direction of the assembly to start it from the left to right, like in your drawing. So we will start from the blind flange in this direction to end at the right head on the right hand side. From here, we will define the delivered blade dimensions, which is the raw material dimension, and let's click Save. Now let's add the first element. From here, we will select the equipment, and from the elements here, we will select the blind flange, which is the first element, and let's make it as B1. So we will name it as B1. And from here you can figure that we have many different types of blind flanges, but let's select the exchanger blind flange. And from here we will define the dimensions of this blind flange as mentioned in your drawings. Okay, that's the flange ID, flange OD, the thickness of the flange, the bolt circle diameter, okay, the bolt hole diameter, the number of bolts, the raised face thickness, the second raised face thickness, the raised face outside diameter. Okay, and from here, let's select the bus partition type. We will select it 6 passes mixed or edge bended, and this type will be clear when we select the gasket. So from here, let's select the bus partition width 13 millimeters, the fillet and the bus partition orientation. This value is very important because we will here we will rotate the tube buses 90 degrees. Okay, and I will show you the gasket orientation to know that value where it comes. Now we will define the bus lane of the bus partitions. Okay, and now let's click on save. Here, if we open SEG and add another gasketed gasket item with bus partition, so let's add G1, which is a gasket with bus partitions, and let's select from here the bus partition type, which is 6 bus partitions mixed or edge banded for front side, which is that type, that image here. We have this type of gasket. So we will rotate it 90 degrees to get that shape of the bus partition. Now we will define the dimensions of this bus partition, the inside diameter, the thickness of this gasket, the width of that one. Okay. After that, we will define the thickness, which is the thickness of the mid piece right here. We will define the bus lane as we defined on the bus partition, the fillet, and the orientation. Okay, let's click save. And from the setting, we will make a rendering for elements during creation to give us the ability to make a rendering for elements during creation on Autodesk Inventor. Now let's click Start Assembly to start creating those 2 elements on SEG. Now we have the first element, which is the blind flange. During that, we will generate the gasket. Okay, now we have this gasket. As you can figure, the rendering of the element during creation takes place. Okay, now let's add the third element, which is this body flange. After that, we will add a can and another body flange. Okay, so let's come back to SEG, and from here, let's add a designed flange. Let's name it as F1. And from here, let's select the suitable type that required, which is integral weld neck flange with including this groove. I hope that you can take a look on the image on the right hand side, the grooved face, flange with a grooved face. Let's define the inside diameter, the end thickness, the neck thickness, after that the neck length, and the flange outside diameter, flange thickness, raised face thickness, raised face outside diameter, bolt circle diameter, and number bolt hole diameter, number of bolts. And from here we will select flipped to make the facing of the flange. Here you can figure the facing of this flange to the right hand side. By clicking on flip, we will make the facing on the left hand side. Let's click save, and let's add a new element, which is can 1. Okay, and from here we will select the shell type. We have many different types. You should select the required type in your case. So from here, let's select shell type, which is a shell including a welding line. Let's define the inside diameter, the thickness, the longitudinal welding line orientation, and the length of this shell course. Let's add another flange, which is the channel flange. Let's name it as F2. Sorry, let's select the designed flange, F2, and from here we will select F1 to make it looks like F1 because they are the same dimensions. So from here we will select F1 and remove the flipped direction to make the facing on the other side, like this flange here, the facing on the other side. So let's come back here and click Save. Now let's click on the assembly to start generating the assembly of the body flange, shell, and the second body flange. And you can figure that the 3D model of the element created automatically and assembled automatically without any user control. SEG will take care about everything regarding assembly and part modeling. After that, we will add a bus partition here on this can. So from elements, we will select the can one. And from here, you can figure that you can add many different attachments like supports, nozzle openings, lifting lugs, external attachments, and internal attachments. So from internal attachment, we will add a front bus partition. Let's add this bus partition. And from here, we will select the suitable type, which is 6 buses that we defined, type A, which is on the cube side. And from here, we will define the dimensions of this tube bus, the thickness, and the end thickness of this one, the extended length on the left-hand side and right-hand side, the chamfer, the pinhole diameter, and don't forget to change the orientation to make it 90 degree. Okay, and from here, let's define the offset from the vessel center line, which is the bus lane location. Okay, the same on the blind flange, and let's click Save. Now, let's click Start the assembly to create the bus partitions. Okay, now let's take a section on this assembly for the channel. So from view, let's take a section, a half section, to figure out the location of the gasket and raised face here and there. Okay, so let's make this section a little bit moved here. Okay, and you can figure that the location of, let's add the other gasket. Okay, and one more point, if you would like to divide your assembly in sub-assemblies, like if you would like to make a separate assembly for the channel, a separate assembly for the tube bundle to prepare a separate drawing, we can do that easily. So from here, we will select any node, and from here, let's add a new group. Let's add a channel, and this channel will start from B1 and end to F2. Okay, now if we take a look to the assembly here, now SEG will start creating a new separate assembly for the channel, and we just need to update it to update the links between elements. So you can figure that the font of each node become blue, and after making run again, the assembly will reassembled again, and you can figure that we have only one assembly here for the channel, which includes all items of the channel, like that. That's an assembly including those items. So you can easily make a detailed drawing for this channel. Let's start proceeding with the next step, which is the tube bundle. Before that, we will need to generate another gasket. between the flange F2 and the tube sheet. So from elements here, we will select a gasketed tube sheet, and let's select G2. And you can figure that the G2, which is the second gasket, is not included on the channel assembly. And from here, we will make it looks like G1 because they have the same arrangement of, if you take a look to the first gasket, the type of the gasket and the dimensions. If you go to the second gasket, after making it same as, you will figure that all dimensions are the same. So you will not need to enter the values again. From here, let's add a tube sheet. So let's add tube sheet 1. Okay. And from here, we will select the required or the suitable type of the tube sheet, which is in our case, it's a tube sheet gasketed with shell and channel extended as flange. Okay, as if we come here, you can figure that the gasket type here is extended as flange. So now let's define the dimensions of the tube sheet. So from here, let's define the outside diameter, the left rest face diameter, the right left face diameter, okay, the thickness of the first rest face, okay, the thickness of the tube sheet, and from here the left rest face diameter. So kindly take a look to the image on the right hand side to know the value of the parameters that you will change. Here the bolt circle diameter and the bolt hole diameter, the number of bolts, and the holing orientation. Here we will rotate the hole orientation to 90 degrees, and from here it's not one pass, so we will remove this checkbox and select the suitable number of passes, which is 6 passes mixed or edge-banded, looks like the gaskets that we select, the fillet, pass partition orientation, the top offset, which is the pass lane or offset of the pass partition as per your drawings here. If you check that, that's the value, which is the offset of the pass partition. So we will define it like that and click yes. Okay, now for this tube sheet, we will start creating the tube pattern arrangement. From here, let's click on tube bundle, and from this dialog box, we will start creating the tube pattern arrangement inside this tube sheet. So from here, let's click edit, and let's define the dimensions of the shell. The thickness diameter is 12, and shell to tube clearance is 20, and the tube diameter is 19.05. The tube clearance on the tube sheet, so you can figure that the tube hole diameter is calculated automatically. It's 19.25. We will define the pitch of between the tubes, the spacing between tubes, and from here we will define the hole clearance on the baffle. Define the top clearance. Let's take a look on those values. If we make a draw, for example, you can figure that if you would like to make a clearance from the left and right, so let's make this value as 190 degree, 190 degree, and let's click draw. You can figure that we will select the area of drawing tubes inside the shell. So let's go to the next step. And from here, let's select the number of the pass partition. So let's select the suitable pass partition for our case. And from here, let's define the perpendicular pass lane and parallel pass lane. If we take a look to this image here, as per your drawing, the spacing between tubes here and there, if we take a look, the spacing here for tubes besides the pass partition is 22 and 22, and the hole diameter with that value. So the pass lane value, which is that value, we will need to define it here. So like that, and that's the bus lane. And let's make the bus partitions are symmetric, because if we would like to move those bus partitions up and down, the top and the bottom will move with each other. From here, let's define the holes. So the tie rod, we will make it 14 as per your drawings, and from here. And the from tube layout, we will make we will select this type, which is hole with this chamfer. And from the tie rod, we will define the tie rod depth and the size of if we take a look to the tie rod here. Okay, we have that's the tie rod penetration, but the tie rod hole depth, we make it 22, and here the diameter and the thread length, so let's make it 12 and like that. The same for ceiling rod, we will make it 22, and from here the size of this one. And the let's make a draw of this tube sheet. You can figure that after modifying the bus partitions, we have this arrangement. The next step, which is the tube layout. Here you can figure that they use the tube layout in this model, which is this type. So we will select the square the type 90 degree. We will select this one. And from here, let's select the position of the big point to be at the center, and let's draw again. You can figure that the orientation of holes will be not connected to the center, because the spacing, which is the mid-center point, which is located to the center line of the tube sheet. So to change it, if we take a look to the tube sheet here, you can figure that we have a hole on this area, on the center line. So we will select this to make it big from the center line of the tube, and let's draw again. You can figure that the tubes here will be on the middle, on this chamfer. Okay, so from here, let's go to the bus partitions locations, and let's move the bus partitions up. Okay, so we move the bus partition up. So if we calculate the number of those tubes per room, we will make a tie rod here and another tie rod there. Here the same for this tie rod. We will remove those tubes, okay, to make it looks like your drawing. Another more thing, we will add some ceiling rod, so we will select the bus partition and add a ceiling rod from here. The same, let's add a ceiling rod there, another one. On the same side, we will make another ceiling rod here and another ceiling rod there. Okay, now let's export those data to SEG to start creating the tube pattern and keep those information for the tube pattern. Before this step, let's calculate the number of tubes. Here we have 45 plus 45 plus 55 plus 55, 56 plus 56. Number of tubes per each room. The total number is 330 tubes. The same number of the tube as per your drawing here. If we take a look, we have 33 tubes, the same arrangement of the tubes, and we rotate it 90 degree. Okay, so let's click export from here. So from this button, we will export the data of this tube sheet, and let's close this. From here, let's add the tube bundle elements. Let's generate a group first for the tube bundle. And let's make it start from tube sheet 1 to the end. So let's add a tube first. Let's add a tube. Okay. And from here we will select the suitable type for the tube. Here you can figure that you have the standard tube with standard lenses, but in our case we will select the user-defined lens and defined the tube length as their drawings, the tube thickness and the tube offset from the tube sheet. Now we have the ability to create a group for the tube bundle. So let's create this assembly first. Okay, now we have the second tube sheet here. And the tube sheet will created without any holes. There is another tool which creating a tube pattern and tie rod pattern and tube holing on the tube sheet, and we will use it after adding the elements to the tube bundle. Okay, now we have this tube. Now let's generate a group for this bundle. And this group will include the tube sheet 1 and the tube. After creating the assembly, it takes seconds. We will click on Start to generate this assembly and arrange the elements inside it. Okay, now let's come back to SEG, and from here let's add a tie rod to the this tube bundle. Let's add a tie rod, and from here we will define the dimensions of the tie rod, the length, the start thread length, the other dimensions, and the nut size. Let's add a sealing rod. The same, we will define the dimensions of the sealing rod. And it's 12. Let's click Save. Now let's click Simply. If we take a look to the this tube bundle assembly for the baffles, we will figure that we have two identical baffles with equal spacing, and the same for the other side here, and for the spacing between baffles are not identical. So we will make a different patterns here for the identical baffles. After creating the tie rod assembly, we will add the baffles and define them. Okay, now let's create the baffles. So we will select the tube sheet, and from here we will select baffle, and let's add B1 and B3. Okay, and from here we will select segmental baffle and define the dimensions of this baffle. The thickness, the clearance, the location of this baffle, the orientation, and let's add a vent and make the value of this vent with 10 millimeters. So let's add on the second baffle, which is B2 and B4. We will make it same as B1 and B3, but we will change the orientation and location for this one. So we will change the spacing, change the location of this one, and the orientation. Sorry, we need to make it looks like this one. Okay, so Here, the location of this one, we didn't define it in a correct way, so the location here is 5, 7. Oh, that's not the material, sorry. So the location here. Okay, the orientation is like that, and the quantity is 2. Click save, and from here let's update this and define the location of the this baffle. Okay, the location is 838.7 and the orientation is 90. Sorry, that's the location 998.99, and let's click save. Let's add the third baffle. Okay, and for this type we will select end baffle, and let's define the dimensions of this baffle. Event height, the chamfer, and let's click save. Now if we click on start simply, that's the first baffle here, which is that one, the first baffle that we create, and that's the second baffle, and that's the third baffle, which is FB. Okay, so if we come back here, here we have those baffles. One more thing we forget, for B2 the required number is 2 baffles, so we will update it and click save. Now let's add the other baffles on the other side, which is let's add those baffles and add those and the end baffle here. Okay, so we will need to add more 3 baffles, so let's add B5 and B7. We will make it looks like B1 and B3, and let's click save. The only thing will change, which is the location. So the location 2676.29, and click save. Let's add another baffle, which is B4, B4 and B6. They will be looks like B2 and B4, and let's click save. The only thing will change is the location, and let's click on save. Now let's add the end baffle, which is SP, and it will looks like the FB baffle. And from here let's define the dimensions and the location of this one, and let's click on save. Now let's click the assembly. After this step we will start creating, we will generate the floating head. After floating head we will make the tube pattern arrangement, which includes the holing of tube sheets, tube sheet holing and baffle holing, the arrangement of tubes, tie rods and sealing rods. Okay, that's the baffle B5 and B7. B4 and B6. Okay, now we have all the baffles for this tube bundle. Let's add the last element right now, which is the floating head. Okay, and let's click Save. And for this floating head, let's define the dimensions. Okay, there is the face. The left face thickness of the tube sheet, the tube length, the extended length, the backing ring outside diameter, okay, the thickness of the backing ring, okay, 0.8, the cut, this value is like that, the hole diameter, number of holes, and splice thickness, the splice width, and the number of holes per splice. On the this side, we will define some dimensions for the gasket. The gasket width, the dimension G, 0.85. Sorry. Okay, so the thickness 11, the radius, okay, the dimension G is thickness 10 millimeters, the radius is 35. The width width, which is the I dimension. Okay, and let's click on Save. And now let's generate the tube floating head simply. Here's the first element, which is the tube sheet of this floating head, the backing ring, the body flange on the other side of the floating head, the splice plate, after that the lifting lug, the stud bolts and nuts. Now we will start creating, after finishing this step, we will start creating the tube holing and the tube arrangement. Okay, so we will come back to SEG again, and from the tube sheet itself, we will go down here and we will open the tube sheet holing. So let's check the assembly. Now it's the assembly of the tube bundle is done. If we take a look at it, that's the assembly of the tube bundle here. So let's make the pattern of tubes. So from tube sheet holing, we will click on Start Holing to start proceeding the tube pattern arrangement. This step may take some minutes because SEG will make a loop for the elements which require to make a holing or patterning here. Now, if we take a look to this tube sheet, you can figure that SEG now draw the location of holes on the tube sheet here. Automatically, everything done automatically. Okay, now the tube holding are done. Let's take a look on the second tube sheet. Now SEG make the hole sketching automatically. Okay, now the step of the tube pattern. Here you can figure that the pattern of tubes. The holing pattern on the baffles. The second baffle. So can you imagine how much time you will save in case of using the SEG tools to make the elements and this stuff of work, like make a holing pattern for tubes and tube sheet and baffles? All of that SEG can take care about it. If you would like in a special case to make some special things, like we will discuss how to make, for example, the eye bolt holing to pulling out the tube sheet outside the heat exchanger. Something like that, we can do it easily, and I will show you how to make it manually, how to add some additional things that you would like to make if it's not included in SEG. But as you can figure, SEG will take care about everything, but sometimes if you would like to add or modify something, you can do it easily by hand. The most complicated thing will be done and generated by SEG. The other things, for small things, if you would like to add it, you can do it easily. The last baffle. After making the tube holing, SEG will generate the tie rod holing on the tube sheet and the baffles. After that, make the pattern for the tie rod and sealing rod. Make the holing for both inside the baffles and the tube sheet. So the last tube sheet here. Now the tie rod locations. The sealing rod locations on baffles, all of that will be done. The tie rod holing on the tube sheet, the sealing rod holing, the pattern of the tie rods and sealing rods here. Okay, now let's proceeding with the other elements of the heat exchanger. Now we make the tube bundle. So let's start from the gasket, which is between the tube sheet and this body flange, and we will proceed creating the other elements of the heat exchanger. So let's come back to SEG, and from here let's select the heat exchanger and let's add a gasket G3, and let's select the user defined and define the inside diameter of this one, the thickness and the width. Click save. Now let's add a designed flange. So from here let's add F3, and we will make it looks like F1, the same dimensions of F1. Okay, so sorry, let's delete it from here. Let's add it like that, which is F3. Okay, and after creating it, we will make it looks like F1 from here. Okay. Okay, and after that we will add the CAN tool. From this one, we will select the shell type, define the inside diameter of this can, the thickness, which is 14 millimeters, and the longitudinal welding line orientation, the length of this course, and let's click save. For F3, we will flip the direction of this flange, and let's add, sorry, it's same as F1. Okay. Let's add another can. So from here, let's add can 2. Let's make it looks like can 2, but we will change the longitudinal welding line orientation. And the longitudinal welding line orientation, the length of the course. The only thing differ between F3 and F4, if we take a look here, which is the end thickness. Here you can figure that the end thickness is 12, but for those flanges, the end thickness is 14. So we will come back to F3 again and change the end thickness to 14. Okay, and let's click Start Assembly to generate the shell elements. Okay, now let's add the second body flange for the shell side. So from here, let's add a design flange, which is will be F4. Okay, in F4, if we take a look the type of this flange here, includes a raised face, not grooved raised face. It's a raised face. So we should take care about selecting the suitable item here. So we will select integral weld neck with a raised face, not a grooved raised face. So from here, let's define the dimensions of this flange: 700, 14, 20, 45, 1000, 55, 5 millimeters. The bolt circle, the raised face outside diameter is 875. The bolt circle diameter is 944. The hole diameter and number of holes. And let's click save. Now let's add another gasket. So from here, let's add G4. Okay, and click save. Now from G4, we will define the inside diameter, which is 849. The thickness is 3 millimeters. The width is 13. And let's click save. Now let's click simply. After that, we will generate the bonnet, which includes, if we take a look here, we will generate this bonnet, which includes this flange, this shell course, and that ellipsoidal head. Okay, here after creating that, we will start creating the bonnet. So from here, let's select this, and from here, let's add a designed flange, which is F5, and let's click on save. and from here we will select this type, which is grooved, integral weld neck grooved, this type. Okay, if we take a look, because this flange including a groove here, so we should take care about that. So from here we will define the dimensions. Bolt circle diameter, or diameter and number of bolts, and it will be flipped. Now let's add another channel, CAN 4. So let's add CAN 4, and from here we will select the CAN and select the type, which is shell type, and define the thickness, longitudinal welding line, and the length of the course. Let's add the last element, which is the end head. Okay, so from here we will define the dimensions. And make it flipped to make the convex to the other side, and from here let's click on assembly to start generating the bonnet. As we discussed, if you would like to make a separate drawing, you can make a group for some elements to prepare them to generate a separate drawing for them. Now, after finishing the bonnet, we will start creating the support saddles. After saddles, inshallah, we will add the nozzles, the service nozzles and lifting lugs for this heat exchanger. Now let's select the CAN one, and let's add a support saddle. And from here you can figure that you have many different type of supports and saddles, like tilted saddle, stacked saddle. From here we will select this type of saddle, which is fixed. And from here we will select the saddle and the whip will be on the left side. If we take a look, you can figure that the whip of this saddle on the left side. So we will select this type from here, and we will start define the data, the saddle angle, the saddle height, the thickness of the whip, and from here the offset is 20 millimeters. The thickness, let's make it 10 millimeters, and let's add outer ribs. So the width of the top, the width of the whip here is different from that one. And if we take a look to the drawing of the saddle, it's in a separate drawing, but here I will define the dimensions as per your drawings. Here the rib thickness, and for the wear plate, let's add a wear plate. So for the wear plate, the contact angle, the width of the wear plate, the thickness of the wear plate, let's add a fillet, and here the base plate dimensions. So the base plate, the width of the base plate, the thickness 25, and the hole diameter is 27. The hole offset from the long edge and short edge, number of rows, the location of the saddle and the whip offset. And let's click save. Now let's start creating the saddle assembly. Let's take a look to the spacing. We need to add intermediate ribs. So here, as per your drawing, we have an intermediate ribs, so I forget to add them. After finishing the assembly, we add the intermediate ribs and create the second saddle. Okay, so let's come back here for the saddle. after finishing it, and now it's simple. So from here, let's add an intermediate ribs and define the spacing between the ribs like that, and the thickness of the ribs. Now let's add the sliding saddle. So from here, let's add sliding saddle. And for this sliding saddle, the web location on the right side. So we will select this type, which is the saddle on the right side, and let's define the dimensions, the web thickness, and let's add outer ribs. Here it's 20 millimeters, the 476 22, and the spacing between ribs, and from here the wear plate and the width of the wear plate, the fillet, the base plate length, width and thickness, the hole diameter, the offset of the hole from the long edge, and here you can make it as a sliding saddle, and from here you can define the slot length. We will define the location of this saddle. Okay, and the offset is 52. Okay, and click on save. Now let's click on start assembly, and you can figure that we will start modifying the fixed saddle to add a new mid ribs on it. After that, SEG will create the second saddle, which is the sliding saddle. Here, those are the mid ribs. That's the second saddle, and the web on the right direction. After this step, inshallah, we will start creating nozzles on the heat exchanger for the channel side, shell side, and bonnet side. Okay, now we have the 3D model of this exchanger. It takes around up to this here. We will select the can, and from the elements, let's add a nozzle, which is N8. Okay, and let's click add, and from here we will select the type of this nozzle as a long weld neck nozzle, the rating of this nozzle, size, and the location, the orientation at 0 degree, and let's define the service of this nozzle as channel vent. Okay, and let's click save. Now if we open the calculator and define the projection of this one and click calculate, okay, now the projection of this nozzle will be 208. Now if we click simply, we will get this nozzle. After creating this one, we will add the another 3 nozzles to the can 1. We have on the channel side, we have 4 nozzles, which is N8, N9, and N5 and N4. So let's add the other nozzles. Now we have this nozzle, so let's add the other nozzles in one time and create them one time. So from here, let's add N9, and from here, let's select it as a long weld neck flange, the location, the orientation, and the name of this will be channel drain. And let's click save with the calculator and we'll define the projection of this nozzle. Click calculate and click save. let's add N4. Okay, now we have the N4 nozzle. It will be a nozzle from pipe, so the size of this nozzle will be 4 inches. The schedule of this nozzle is 120. The location is on that value. The orientation and the service of this nozzle is cooling water inlet. And let's click save. Now let's add a flange to this pipe. So from here, N4 flange. Okay, so this flange we will select weld neck raised face according to ASME 16.5. Select the rating, the size of the flange, and the schedule, the same of the flange. Now we will come back to the nozzle, and from here we will open the calculator to define the projection of the nozzle from the face of the flange. So from here we will define the projection as 650 as per your drawings here. That's the projection of the nozzles N8 and N9, and on another view here, that's the projection of N4 and N5. So let's come back here, define it by that value, and click save. Now let's add another nozzle, which is N5. So from here, let's add N5 and click save. And from N5 here, we will make it looks like N4, okay, to avoid repeating data again. And from here, let's add another flange, which is N5 flange, and click save. And from here, we will make it looks like N4 flange, and click save. And for N5, we will change the orientation of the this nozzle. So we'll make it the orientation on 90 degree and the name of the nozzle or the service of the nozzle outlet. And let's click on save. And now let's start the assembly to start creating the 4 nozzles in one time. Here we will start with N9, which is a long weld neck nozzle. N4 nozzle, which is a nozzle from pipe. The last nozzle, which is N5, and it's a flange. Okay, now let's add the bonnet nozzles. Let's start with the shell nozzle. Now we have those 4 nozzles here. Let's add the shell nozzles. So from here, let's select CAN 3, and from here we will select the nozzle, and let's add in 10. This nozzle is a long weld neck nozzle, 2 inches, and the location of this nozzle, and at 0 degree. The service of this nozzle as shell vent. Click save first. After that, we calculate the projection, which is like that, and click calculate to calculate the projection. Let's add another nozzle, which is N1. So let's add N1, and from here we will select the required type, which is a helicide or radial forged hub. Like that case, we have here this nozzle is a forged hub nozzle. So from here, let's define the size as 10 inches, and the schedule is 40s, and let's define the location and the orientation at 0 degree. The hub dimensions, that's the hub height, the hub thickness, and the bevel height. And from here, let's define this nozzle as service process gas inlet. And let's click save. Now let's add a flange to this nozzle. So from here, let's add a new flange. We will select ASME B16.5, the rating 300, and from here let's select the size and the schedule. And let's come back to N1 again to define the projection after adding this flange. So the projection here is 700, and let's click calculate. Now we have the projection of the hub. Let's add another nozzle, which is N2. And in N2, we will make it looks like N1 right now. And after that, we will make some modifications like changing the orientation and size. It's 8 inches, the same schedule, the location like that, and it's on the orientation 190 degrees. The hub dimensions 150, the hub thickness is 40, and the bevel height. And here it's gas outlet. And let's click save. Let's add a flange to this one, into flange. We will make it as a rigid face, size 8 inches, schedule 14 is, and click save. Now if we come back to N2, we can define the projection as 700 to calculate the correct value of this one. Now let's add the last nozzle on the shell, which is N3, and we will make it looks like N2 and click save. Let's add another flange, N3 flange. After adding it, we will make it looks like F2 flange, because they are 8 inches, both of them. And for N3, we will change the location. And the same for the orientation, it's on 190 degrees. Now let's generate the assembly of nozzles on the shell side. Here we take a look to the assembly. The last step for nozzles, we will add a vent and drain nozzles on the bonnet. After that, we will add the sealing and sliding bars. Here, as you can figure, we have sealing bars here, and we have sliding bar there, 2 sliding bars. So another view we can check from it here. That view is a little bit clear for the height of those, and another view here for the sealing bars. And we will, after adding the drain and the nozzle, drain and vent nozzles for the bonnet, we will proceed with creating sealing and sliding bars for the tube bundle, inshallah. Okay, here if we come back to the model here. The last nozzle, which is N3 on the shell. Okay, now we have the nozzles are created on the heat exchanger like that. Now let's add the last 2 nozzles on the bonnet. So let's select the channel of the bonnet, and from elements let's add N6, and from here let's select this one. It's a long weld neck flange with a rating 150, the size and the location 150. It's in 0 degree, and the service is cover drain, cover vent. Okay, so that's the cover vent, and from here we will define the projection. Okay, let's add another nozzle, which is N7. N7. And it's a long weld neck flange. Define the location and the orientation. Cover drain. Click Save and define the projection. Okay, and click Save. One more thing I forget to tell you about it, which is the weld detail. From here, you can define the weld detail to make it appear on the drawing and the nozzle table. Like if you would like to make the weld preparation with a double V or single V, you can add a clad detail or not, but in our case it's without clad, and you can define the root of the fillet or the height of the fillet. So let's make it 10 millimeters for example. And if we take a look to the nozzles on the nozzle table, here you can figure that we have here, those are the nozzles, the description or the service of the nozzle, the size, orientation, outside diameter, facing, and the welding style of this nozzle, and the projection, by the way, from the vessel center line. Okay, let's create those nozzles, which is N6 and N7. After that, we will proceed with the sealing bars. So let's come back here to the SEG. Okay, now we are done the all nozzles on our model. The next step, we will add some. If we take a look here, if we take a section, half section for example, here we will add some sealing and sealing bars, top and bottom, and add sliding bars. Now let's remove the section, and from here let's select the tube sheet, and from the elements let's add sliding or sealing bar. So let's add sealing bar, A, and from here let's select the suitable type we need to add. So we will divide this. We will make, because those are symmetric with the same height, we will make them as in one time, and those we will make them in one time. Okay, after that we will make the same at the top. So let's come here and select that one is a double vertical, which is that one including spacing and length, and let's define the dimensions, 6, the clearance, and the length, the height, the location, the orientation, and the spacing. Okay, the height here it's included on this drawing, the height of each sealing bar. So we will add another sealing bar here. B. We will make it looks like seam bar A, but we will change the height and spacing. So the height we will change it, and the spacing between the two bars. Okay, let's add another. Sorry. Select the tube sheet. bar C, and we will make it looks like seam A, but we will change the orientation. Let's make it at 0 degree and change the height. And let's click on save. Let's add another ceiling bar. We'll make it same as C or D. Okay, let's make it like that to keep the spacing, and we will change the orientation to 0 degree and the height of this one to 85. And let's click on Start Assembly to start creating the ceiling bars. Now we will, after finishing this step, we will add the sliding bars. Okay. After that, we will add some lifting lugs, stud bolts, which is the connection between flanges, the stud bolts, which tighten the two flanges with each other. After that, inshallah, we will proceed with the drawings of the heat exchanger. That's the last sliding ceiling bar. Here, after adding it to the assembly, we will take a section to figure out. Here we have those ceiling bars like that, top and bottom. Here. Okay, now we will add the sliding bars. So let's remove this section and let's add the sliding bar. We will select the tube sheet and add sliding bar like yes, and from here we will select the suitable type for this sliding bar, which is a double radial, which includes an inclination angle between them. So let's define the dimensions. Of this one, the orientation and the inside angle, and let's click Start the assembly. Now let's take a section here, and you can figure that those are the sliding bars. Now let's add some lifting lugs as per the drawings. From here you can figure that we have many different types of lifting lugs. We will select the suitable type in this case, which is lug 7. So channel lug 1. And let's define the dimensions of this one. The dimension C, the offset, the thickness, and the hole diameter. Let's add let's make it with a fillet without a chamfer. I think it's not including a chamfer here. Yes, it's with a fillet. So we will remove the checkbox of the fillet. And from here, let's add the wear plate dimensions, width, wear plate, and the location 145 degrees, click Save. Let's add another lifting lug on the shell. Lug 2, and we will make it looks like lug 1, but we will change the orientation to make it on 350 degrees, and let's click Save. Now let's start creating the assembly of lugs, of the lifting lugs. The second lifting lug on the channel. Okay, now let's add the lifting lugs on the shell side. Now we have those lifting lugs on the channel, and you can figure easily if there is any clash with welding lines or not. Something like that, you can make a visual inspection easily by using the 3D model to check if you have any issues before manufacturing the process. Now let's select this can and add some lifting lugs here. Shell lug 1, and let's define the dimensions. Remove the chamfer, the wear plate dimensions, fillet and the location. Orientation is 30 degrees, and another one to the shell. We will make it the same with shell lug 1, but we will change the orientation. We have 4 lifting lugs for the channel. If we take a look, we have 4 lifting lugs, 2 on this side and another 2 on the other side. So let's add another 2 lifting lugs. So lug 3, we will make it looks like shell lug 1, but with the same longitudinal, with the same orientation, but with another location. So the location in this case will be like that. Another lug, which is the last lug, shell lug 4. We will make it looks like shell lug 2, but with another location, which is 3612. Click Save. Now let's click Start the assembly. After this step, inshallah, we will make the connection bolts for the flanges and the tube sheet, and add some attachments like if we would like to add a blind to the vent hole or the drain hole, how we can make that with the plus adding the stud bolts, adding a nameplate. After that, inshallah, we will proceed with the general arrangement drawing and some other drawings and the content of the drawing, and how we can control the content, like if we would like to export the bill of material, nozzle table, and other tables to our drawing. That's the third lifting lug. One more lifting lug is there. Okay, now we have those lifting lugs on the shell side. And you can figure that here, this longitudinal building line orientation, we may need to change it a little bit. So, for example, let's make it on for this shell. So let's select CAN 3. And from here, we can change the longitudinal welding line orientation. So let's make it on 110 degrees and click Start to change the longitudinal building line orientation and figure out how it far from the lifting lug. So we can minimize the value with 5 degrees to make it between the lifting lug and the wear plate. So let's come back and change this 105 degrees. Click Save and start the assembly to move it a little bit up like that. Now I think it's far from the, if you would like to measure the distance, for example, from the inspect tool, we can measure the distance from that line to this point. We have 58 millimeters. So if you would like to change the orientation of the welding line, now you know the way how to do it. Now let's add some attachments for the blind and connected bolts. So from here we will add a stud bolt to connect B1 with F1. So let's add B1 stud bolt, and from here we will select the type of the nut, which is UNC nut, and the size will be 1 inch. The stud length will be 220, and the knot spacing will be with that value, which is here. If we measure it, the knot spacing from here to there, from that face, so that will be the values that we need to define it here. Now let's add another connection between F2 and tube sheet and F3. So from here, if we select if we select F2, we can add F2 stud bolts here, and the same we will select UNC nut and size, the length of this stud, the spacing. Okay, the same we can measure the value of the spacing between nuts from here to there. Okay, and let's add another stud for between N4 and N5. So from here let's add F4 stud. Okay, so from here let's select UNC, select the size 1 inch, define the length and the nut spacing. Now if we click Save and start creating the assembly, we will get the stud bolts assembly. You can figure that the nuts and bolts will be generated and assembled automatically from SEG library. Okay, we have here the bolting. the last tightening bolts, which is connect F4 and F5 flanges, the flange of the bonnet with the shell flange. Here, as you can figure, after adding the tightening bolts on the flanges, let's add one more thing for the vent hole. Let's make one sample of those. Let's add a blind flange here with the tightening bolts. So from here, let's select the nozzle in 8, the external connection of this one, and let's add a gasket in 8 gasket. And from here, we will select the required or the suitable gasket, which is a raised face gasket according to ASME, and select the size of the gasket. Now let's add a blind flange. 8 blind. From here, we will select the raised face blind flange according to ASME and make it flipped to make the facing of this one to the gasket facing. Now we have this vent nozzle with blind. Now let's add stud bolt here. So we select the blind flange and in 8 stud. So from here, let's select the UNC, and the size of this one is 5 by 8, and the length of this one like that. And let's add a lifting lug to the blind. Okay, if we take a look here, we have a lifting lug on the blind flange. So let's select the flange, and from here let's add a lifting lug. If you would like to make it with a chamfer or with a fillet, so let's make it like that, B1 lug. And from here we will define the dimensions. The width, let's keep this value 10 millimeters as the pinhole. Let's make it 30. The radius, let's make it 50, and the hole offset, make it the location 30 millimeters, orientation at 0, and let's click save. Now if we click the assembly, we will start creating the lifting lug. After that, the stud bolt of the nozzle. Now we will add a nameplate to this heat exchanger. After that, I will show you something we discuss it during generating the tube bundle, which is if you would like to add some more details like the bowling eye bolt holes on the tube sheet, how you can do it by using Autodesk Inventor, and it's easy to do something like that. But before that, let's add a nameplate here. So let's select can 2, and from elements let's add an external attachment. You can figure that you have many different elements you can add it. Let's add a nameplate, and from here, if you select the nameplate, you can figure that you have many different types of nameplates. So let's select the suitable type for our case, which includes this one, for example. If you would like to add an ASME nameplate or client nameplate, you can add it. We will just add a bracket for that, and let's define the location of this one. So let's make it 1002. 200, and let's click on start to add this nameplate bracket. Okay, now let's make a modification on the tube bundle. If we select the tube bundle from here, which is this one, we can open the tube sheet one. So let's open it. And on the other side, which includes the pass partitions, we would like to add 4 holes for the bowling eye bolt. So how we can do that by hand? If we select this surface, for example, you can add 4 points like this and define the location of each one. So let's make it this, for example, like that, and from the center line, and let's make the others. Okay, so let's define the offset from here. Looks like this. Now we have those 4 holes with the same dimensions, and we can use them now to make a holing. So from here you can select the feature of the holing, which is that one, and automatically you can figure that the whole configuration is selected for the 4 points. And from here you can select the if you would like to make it with a distance, hole with a distance like that, and if you would like to add a thread on it, so you can define the thread length. Now you have full control on the hole shape that you would like to generate. So let's make it 30 millimeters, for example, the depth of this hole, and you can select let's make it isometric profile and select the size of the hole like that, and let's make it with this one. Let's make it 24, for example, and here the total length is 26 here, 90 degrees. Okay, now we have this hole with a thread, so if we click on OK, we can get the whole pattern of the tie of the eye bolt that we would like to generate. Something like that, or a modification like that, you can make it easily by hand if you would like to add something to your model, and it will be reflected automatically to the drawings. Okay, now we have the 3D model. And if you would like to add insulation to it, like in your drawing, as we mentioned on the 3D model that our technical team created, from the can side, for example, if you would like to add an external attachment, you can add insulation from here. So just you will define the insulation thickness density to calculate the weight of the insulation, and you can get it in your 3D model. Now we would like to know more how we can get the bill of material of this heat exchanger, and how much number of nozzles and the tail of nozzles. If we take a look to the tables here, we will find the bill of material table, and here in seconds SEG will calculate the bill of material of this heat exchanger. As you can see, we have in this model 920 elements in this model, and here SEG will take care about the identical items. Like for example, here we have tubes. We have 330 tubes are identical. For nuts, we have 132 nuts from UNC1 with the same material and the same weight. If the material is different, SEG automatically will separate them. If the type is different, SEG will separate them and give them a separate item number. So you can figure easily that SEG calculate the bill of material with the weights. So the total weight of this heat exchanger is around 7.3 tons. here the weight of each element, the material of each element, and the technical characteristics of each element. Like if you have an ellipsoidal head for the last head, they defined it here as an ellipsoidal head 2/1, the height per the diameter, the inside diameter, nominal thickness, and the minimum thickness after forming, and the straight flange. For seamless nozzles, which is they are standard parts, you can figure that the description of it. It's NBS 4 scalable 120, and the length of the pipe. For the flanges, the standard flanges will be defined like that. The NBS 2 long weld neck flange with the raised face. The class of the flange is 150, and the length of this flange and the end thickness. Like that, you can get the description for elements, for standard and non-standard elements. For example, here for this forged hub, the size of the forged hub, the hub thickness, the length of the nozzle, and the end thickness of this hub. Okay, now let's take a look on the nozzle table. As we discussed from minutes, the nozzle table includes the nozzle tag, the nozzle service, the size of the nozzle, the outside diameter, many different fields regarding to the nozzle, like projection and reinforced band, welding detail, all of that. And if you would like to make some modifications and remove some columns from here and keep, what would you like to keep? So from the columnar setting, you can select and choose the required columns that you would like to export it to your drawing by selecting it and select that is this checkbox. Now let's, if you would like to get a list of flanges, you can, by clicking on flange, you will get a list of flanges. The same for gaskets, if you would like to get a list of gaskets. Fittings, if you have a fittings. The nozzle orientation, the orientation of all nozzles in your project. And you can get an estimated material cost report by defining the price of each material per ton, and SEG will calculate the estimated cost for material. Now let's generate a detailed drawing for the channel, for example, before making the general arrangement. Here, as we discussed on the beginning, we make a separate groups for the channel and the bundle to show you how, if you would like to generate a separate drawing for this assembly. So here we have this channel, which is include the blind flange and its attachments, the shell and flange. Now if we select the channel itself and right click on it, you will get this list, and from here we will select drawing and select create drawing. Now we will select the size of the drawing. Let's select A2, and from here select the orientation of the drawing, landscape or portrait, the location of the title block. If you would like to make it right bottom or top right, or select the suitable location for your case. And from here let's select the elevation view, and let's select the right view. Okay, or let's make it as a one view, which is elevation only, and take a section on it if you would like to make something like that. Or you can make it with another side. So let's make it spacing between them like that. And here that's the elevation orientation. If we open the channel, for example, if we take a look and open the channel here, that's the assembly of the channel. Let's make the UCSs disappear, and from here that will be the elevation view. If you take a look to the left view, that will be the elevation view. If you make it front like that, that will be the elevation view. So from here you can select the suitable elevation view for your case, and in this case we will make it front. Okay, so to make this as the elevation view. Okay, now let's define the location of the view on the drawing and the scale, and let's add a bill of material in this drawing, and let's add some notes. If you would like to add some notes, you can edit or add or modify if you would like. For example, if you would like to delete this, just select the node and delete it, and if you would like to edit, select the node and click edit to be able to edit it. And if you would like to add, just write your new node and add it to be added to the nodes. And if you would like to import it from an Excel sheet, you can import it directly from here. Now we will select some welding details, suitable welding details to our case. We have flange, welding flange to shell, and another welding detail for we have this, and no more welding details required, so we will click save. And right now we will define this as a channel drawing, and it is DWG, and from here define the revision table. Okay, and let's click save. Now let's add some empty rows, and from the design data we will keep the location of tables and click on create drawing to start creating the drawing of the channel. Here's the revision table and the bill of material of this channel. The general notes and the welding details. Now, if you would like to change the location of the views and the scale, you can make it by hand, but anytime you will need to make update, it will be updated according to the data that you saved in SEG. So it's better to modify it from SEG itself. So from here, let's come back to the drawing, and from drawings here, let's click on create, and let's define the location of redefine the location of the that one and increase the scale a little bit, and click on create to update the dimensions of this one. Now let's add some dimensions and annotations here and there. So let's select this one like that. Now let's add center line here and there. Now let's add a projection of the nozzles as per your drawings. So from here to there, as we discussed, it should be 650 for nozzle N4 and N5 like that, and for the N8 and N9 it's 570 from the facing of the nozzle like that. Now let's add some balance for nozzles. So let's add a nozzle tag. So here we select the flange. After that we will modify our selection to select the nozzle itself, but let's add right now the flanges. After that we will modify it. We have those nozzles, sorry. Select nozzle tag. Okay, continue. Now we will select the nozzle instead of flange like that. We will select the nozzle and remove the balloon of the flange like that. Now if we would like to define the offset of the pass partitions like that, we can do it easily from here to there as defined it in drawings. And for the lifting lugs, if we would like to change that one, let's make it aligned to edge like that. The same for this, let's make it aligned to edge, and sorry, aligned to edge, and select this edge. Now if we select that, we can, for example, if you would like to make it outside here like that, you can make it outside exchanger. Okay, so by that way, we defined the general dimensions of this channel. And if you would like to make a separate detailed drawing for the this blind flange, for example, we can add it on the drawing. So we can make a modification on this one to move up the change that one to make it on like that. So we moved this view up, right, like that. And if you would like to add a detail for the blind, for example, so let's open the blind flange here, open. And now we can import it to the drawing, like that. You can move it like that if you would like to change the scale. And let's add the bolt circle diameter. Sorry, we can make it from automated center lines, so we can do it like that. So we get the automated center line from here. So if we open the hole and thread, we can get the definition of the hole. We have, if we would like to add the number of holes, we can modify it easily from here. If we define the quantity by that way, like that, and add the number of holes like that. So we have 44 holes with 28 hole diameter. By the same way, you can take a section if you would like to add a section for this blind flange like that, and make another detail for this area, for example. That's just an example to give you the what can you do with that. So if you would like to add dimensions like this. So if you would like to add a clearance for this thickness, for example, so from here, from the, if we double click on the dimension, and from precision here, if you would like to make it a deviation, you can make, for example, it's just for example, so you can make it like that. So like that, and make the precision is 1 degree, and you can control the size by the way of the precision. So if we come back to the management, you can change the text style dimension. So if we go to the linear and tolerance, you can change the size and control the text size dimension from here. For example, if you would like to minimize it, you can change the scale to, so you can control on that easily by using the default setting of the Autodesk Inventor. Here, if you would like to add the location of nozzles, you can add it like that from the facing of each nozzle, the orientation and the projection of the lifting lug. For example, if we would like to add a detail for the lifting lug, so let's open that one and open the lifting lug. And if we come back here and let's add a lifting lug detail, define the that one. Make it as a channel. Okay. And if you would like to make it perpendicular, just so we will rotate it and make it vertical like that. Okay, and let's add the dimensions to this lifting lug. Measure from here to there, or if you would like to measure it from here to there, reduce the thickness here. And if you would like to take another view to define the rear blade width, for example, something like that. And if you would like to add a weld sample, so let's add this as like that. If you would like to add a weld sample here or there, so something like that, you can do it easily. So 60 millimeters around, typical. Okay. The thickness of that one, the thickness of the wear plate, and if you would like to add 3D view or isometric view for the lifting lug. You can add and edit or modify. So let's make it shaded, for example. Something like that. You can do it easily by using, after creating the 3D model, you can do anything that you would like to do. Now let's generate the general arrangement drawing. Now we have this drawing for the channel, and let's generate the general arrangement drawing for the heat exchanger. So from here, let's select A1. And from here, let's select two views for the elevation view. Let's keep only, okay, let's add two views, one on the left and another on the right view. The spacing between views, let's make it 3 millimeters. And the elevation view will be the left view. So here, that's the left view. And we will make that one at the elevation view of the detail. Now let's make it 12, add a bill of material, add the design data, add the nozzle table, and from here let's check the welding details if we would like to add more welding details, like the attachment of the saddle, any other attachment here. Okay, save this, and if you would like to add a client document list or vessel document list, add maximum allowable nozzle load if you have, you can export it. Now DWG. Okay, and from here let's edit this as a revision 0. Okay, let's save that, and let's add some empty rows. Delete the first row from here, and from the design table let's save this and start creating the general arrangement drawing. As you can figure, the size of the drawing will be modified automatically. The view locations here, we will need to minimize the scale a little bit. So after creating, we will minimize the scale of the views, and you can figure that the revision table here, the bill of material shall be generated automatically. And after creating the GA, we can figure for the first run of the GA, we can figure that sometimes we may need to separate the bill of material in a different sheet. Okay, because the GA drawing includes a lot of information, so we may need to separate the bill of material in a separate sheet to save some area on the general arrangement drawing, and we will check how we can do that, inshallah, for this drawing, because this heat exchanger include a huge bill of material, little bit, and you can figure the design data will make a clash or laid on the bill of material table, so we can move or separate some tables on another sheets on the same drawing, and we will check how we can do that, inshallah, after making the first generation of the GA. Here, that's the general nodes, the nozzle table. The client document list and the vessel document list. All of that, you can figure that it's generated automatically without any user selection, or just you will define what you would like to export it to your drawing, like welding details, the tables that you would like to export, and it will create it automatically. By the way, if you take a look to our videos, in some training videos that we uploaded on our channel on YouTube, you can figure that you can create your standard reference drawing, or your which includes your title block and your border, to use it as a reference drawing. Now we create the general arrangement drawing, and you can figure that we have the design data table and the bill of material table. They are clashed here, and we could separate them. So let's go again to the general arrangement, and let's delete this drawing and make some modifications here. The first thing, we will change the location of that view and increase the scale, minimize the scale of the heat exchanger. And from here, from the design data table, we will select design 2, which includes 2 sheets. And we will separate the bill of material here. We will separate the bill of material to make it on sheet 2. Okay, and let's click save. Now let's click on create to start creating the general arrangement drawing. Again. That's the second sheet, which includes the bill of material. And if you take a look to the tree on the left-hand side, you can figure that we have sheet 1, which is the main sheet, which includes the views of the equipment. And here the second sheet, which includes the bill of material. The bill of material now updated and modified. Okay. The other tables will be generated on the sheet 1 here. That's the sheet 1. Here we have this drawing 2 sheets. The first sheet, which is the general, the main sheet, which includes the exchanger dimensions, the exchanger views. Okay, now we done the general arrangement. And if you would like, for example, to make this view without any heading lines, you would like to make it with visible lines only. So let's come back here, and from the drawing itself, from the views, we will select this type. The first type, which includes the hidden lines. This one, we will remove the hidden lines. And let's increase the scale a little bit and click on drawing. And you can figure that we remove all the hidden lines on this drawing. Okay, what if you would like to make this view includes the some hidden lines for let's say for baffles, for example. So for example, if we select this shell, and from here, if you select the main assembly, which is this one, and you can figure that you have the bundle assembly that we have, and from here you can make the baffles simply appear. So from here, let's show those baffles. You would like to show the baffles only, not any other items. So from here, let's select the baffles and make them with hidden lines. So you can show the baffles only like that. That's the sliding bar, sorry. So remove that one, and we have another sliding. That's the baffles here. We have those baffles to show the mid baffle and the last baffle here. Okay, so by that way you can add or show some elements that you would like to show. Here, let's add some dimensions to this one. The projection of this nozzle. And by the same way that we create the channel drawing, you can add some details like saddle detail. And if you would like to create a separate detail for the saddle, you can generate it by the same way by creating a saddle drawing. Okay, let's add some details for the, let's say for the baffles. And you can figure that the baffles here, if we open the bonnet simply, if we open the bundle assembly. Let's open the bundle assembly. And let's open one of those baffles. That one, it's not include the cutting of the ceiling bars or sliding bar. So how we can do it, because SEG not do it right now. So from here we will select the element itself, and let's create a new sketch on it. And from here let's define the or project the area of the ceiling bars or the sliding bars here and here, like that. For example, for that one we have this sliding bar. Let's make a sample only, it's not for all elements, so let's make it like this. And now let's make a cut for this one. You can make the 4 elements in one time, but let's make it with cut. Okay, and let's make it like that, so you can get a cut for this one on the baffle like that. If you would like to make a chamfer or something like that, so from the 3D model, let's make chamfer here over there, define the chamfer value, let's make it 5 millimeters. By the same way you can define the other, and you can figure that you have or you get this cut here. Now let's add a detail for this baffle, for example, on our drawings. So if we come back to the general arrangement drawing, for example, now we have this baffle, and if you would like to add a detail for this baffle, for example, if you would like to add some center lines, automated center lines, if you would like to add it, you can generate it automatically like that. And let's take a view for some of those here. Here, that's the view. Change the label. Sorry. Okay, and from here you can define the hole diameter. Okay, the hole spacing. All of that you can define it like that. The same for the location of nozzles and everything, you can do it by that way. Okay, I hope right now we can we cover a lot of things in less than 2 hours. We generate the complete 3D model of the heat exchanger with all details, I think, which includes the, if we take a section, for example, here we have the pass partitions. Here we have those pass partitions. Okay, everything here we generated on the 3D model. And we generate the general arrangement drawing, which includes the bill of material. And by the way, one more thing for the bill of material here, we will make a small modification to make the arrangement from top to bottom and change the widths. This one, and click save. Now let's move it to here. And now we can split it at say 56. So from here you can split it. So now you can make a separate bill of material as we discussed with the for your equipment. So I hope in this session we covered a lot of your requests or questions regarding to the heat exchanger and how we can generate something like that in minutes. I think we didn't take more than 1 hour and 50 minutes.
It's done in 1 hour
Yes.
55 minutes.
Yes, to generate the 3D model with all details of the tube sheet and some detailed drawings for a channel and the general arrangement. Let's say for a professional one, it may take between for this heat exchanger, but because all of us knows that it depends on how much data on the model you will enter. Sometimes it may take 30 minutes only to generate an equipment because it includes shell and head, 2 or 3 nozzles, but some models includes a huge number of elements. So it will take some time. For this model, for a professional one, it may take between 4 and 5 hours to generate all details. Let's say for a startup one, it may take 8 and 10 hours. To be familiar with this one, we'll create it step by step and revise what he did. So let's say for 8 or 10 hours, 1 day, instead of 5 days of creating the drawing. And you will get the complete 3D model, so you can make a checking, make a very professional drawings for your equipment.
Just
And
hold on,
here
Mr. Ahmed.
Yes.
I think Mr. Chopin is saying something, but we are not able to hear him actually.
No, we are not saying anything. I just on the speaker.
Okay. Okay, no problem. No problem.
Again, please,
continue.
again.
No problem. Please continue.
Okay, here I will show you some samples for real projects that we create. For here, let's open the samples. Here, if we open that one, sorry, for the where it is. For example, that's one of our sample projects that we create. So you can figure that you can get all of that automatically. Any modification on nozzles or bill of material, it will be reflected automatically to the GA. Includes the welding details, the nozzle orientation. Here, the bill of material generated automatically, and another details for the internals. All of those internals created by SEG for this desalter unit, and you can generate a professional drawings like this, including a 3D model to show you how to show your customers that you making a professional work, and it will not take some time from you. Actually, when you become familiar with SEG, you will deal with those drawings easily and the 3D model easily. Here, that's a detailed drawing for the manway, a nameplate, a separate detail for saddle detail, for example, pipe support detail. All of that you can do it easily. And let's take a look to some things we created for storage tanks. For example, here's some drawings for storage tanks generated by SEG, and if we here some samples for pressure vessels like that. All of that here you can figure that all of those equipments created by using SEG, stacked heat exchanger ducts, spherical tanks, vertical and horizontal pressure vessels. So SEG is the only existing software can do all of this stuff here. That's all of this stuff of equipment, like spherical tanks, storage tanks with fixed roof, ducts. By the way, you can make ducts, complicated pressure vessels like this vessel. Okay, you can do it easily by using SEG. Another, we have some You can make a slug catcher by using SEG. Okay, and those samples are done by using SEG. Many different things you can do. And in SEG helper, you will find some lifting cranes. You can use it to make a lifting simulation. Like if you would like to check something like that, you can visit our channel on YouTube to figure out some videos for the lifting simulation for some pressure vessels. Here, that's a comparison between the real lifting simulation case, the real case, and the simulation case that we did by using the library of SEG, which includes some cranes. Okay, a lot of things you can do it with SEG, by the way. Okay, do you have any questions regarding the session of today?
Yeah. Regarding the bolt, for the second, whether the 2 feet and flange geometry, in our model, I think it is collar bolt, but we couldn't see collar bolt arrangement here.
Yeah, as mentioned in SEG, you may need to make some modifications by hand, like that we did here on the tube sheet for the eye bolt. For example, if you would like to make a special bolt for, let's say, a special bolt here includes 2 nuts on one side, not one and one. Two nuts on one side and one nut on the other side. For example, how we can do that. So let's open the SEG helper. That's the helper of SEG, which will generate a library for Autodesk Inventor items. We will use it here. So from here, let's create a new part. Okay, sorry, let's from new here. We will select SEG items, and from the accessories, you can figure that you have an eye bolt, by U-bolt, something like that. You can add it manually. So let's select a bolt, not a stud bolt, for example. You will make a bolt with 2 nuts from the other side. So let's select this bolt. Okay, and from here we will open the iLogic library, for example, and select, let's make it UNC bolt. Okay, and let's select the size of this one as 1 inch. Okay, so SEG will change the second nut offset, and let's change the total length of this one. So let's make it like this. The second nut location, let's make it 150. For example, the part number and all of that. Now let's save this. So from SEG and from the assembly, we will save this document, and from here, bolt UNC1. Okay, let's create a new bolt, and from here, let's select the nut. Let's make it UNC. One minute, I will come back. 1 minute. Sorry. And from here, we will select the size of this nut to make it 1 inch. And let's save it. So from SEG, we will save this nut. Okay. And now we will generate a new assembly, includes this those elements, sorry, that we create. That's the UNC bolt, and let's add this nut. Okay, so from here, and let's add another nut. For example, we create a new stud bolt here with 2 nuts. If you would like to add a washer or something like that, you can generate the items that you would like to add if it's not included in SEG. After that, you can add it to your model. Now let's save this as UNC bolt. And if we come back here to the model, you can import it like that. Even you will create it by hand or by using the helper if it's included on the helper. By the way, that's the SEG helper. Here it includes some cranes, some shackles, transportation truck, some transportation saddles, so tilted or straight or davit, saddle on the cone. So you can make something like that. If you, as mentioned, you can do it by hand. As you can see, SEG will cover 95% from your requirements. And if you would like to add something else, you can generate it or add it to your drawing, to your 3D model. And by the way, it will be reflected to the drawing. Something like that. If we come back to the drawing here, as you know, the CAD softwares deal with that, so you can figure that the element will be add here on your 3D model. Okay.
What is our question? If you see in tube sheet and body flanges, in tube sheet, shell flange and body flanges, in between, you have marked some white color bolts here. You can see in your figure itself. That are the color bolts. That is the color bolt.
Would you mind to say your question again, because I cannot hear you clearly?
If you refer our drawings, in the bundle drawings, if you say, you can see counter bore on the tube sheet hole, not on the all bolts, some of the bolts.
Counter bolt.
Yeah.
You prepare the counter bolts hole, but this stud is different type. It's a collar bolt, so we can't see that configuration here.
This collar is integral part of the bolt.
Can you open our drawing, bundle drawing?
I think you are talking about this hole. Is that right?
Yeah.
Okay. Okay. As mentioned, you can make your editing as you would like. Here, SEG create a hole. If you would like to make a modification on this hole, you can do it easily. For example, here, let's open the tube sheet. As we discussed, we make a hole for the for that one here. We make that hole. By the same way, you can do the same thing for any hole you would like to generate. For example, here, if you would like to make 2 or 3 holes with a large diameter like that here. So you will define the required diameters that you would like to do, and by making a simple extrude, you can define the value of this one, and let's make it with 5 millimeters, 10 millimeters, like that. Okay, something like that, you can control it. For example, you would like to minimize this value. Anytime you would like to minimize this value, you will come back to the sketch and define this value. If you would like to make a pattern for this hole, just select the features that you did and select the model. We will make a circular pattern, sorry, so we will select this one, select this feature, and we have 44 holes, so let's make it 11 holes. So we will pattern this on 11 times, something like that. Okay. I hope my point is clear now.
Yeah. So you can make it easy.
Okay.
But the huge stuff or the huge work, you save it.
Yeah, understood. We understood. And for this matching, we can prepare color bolt as well, right? In the modification, can modify the bolts in the bolt section.
I don't get your point.
So to match with this configuration of the tube sheet, we can modify the stud as well. Can you open our drawing once again?
Yes.
No, no.
This drawing?
Okay.
Downside. Downside.
Down?
Yeah, down.
That's the
Right side, yeah, right side. Yeah, see colorboard details.
yes, this detail you are talking about. This detail.
It's an integral part of the board.
Yes, I know what you are talking, and I hope my point is clear now. Something like that. If you would like to create it, you can create it manually.
Yeah, totally.
Or make some modifications to to SEG item. For example, if we create a stud bolt like that one here, we have this stud bolt. Let's make it. Let's change the length of this one like that, and let's make it 20 millimeters diameter. Okay, and let's change another spacing. For example, you would like to make some modification to this bolt. Okay, you have many options. If you would like to select this plane and create a new feature like this. Make rotate for this one, something like that. Okay, delete the UNC, make a suppress for this one, and make a thread here on this face, and change the orientation of this face. Select the let's make it as a metric profile. For example, the size of this stud. Sorry. Isometric table. Select the standard that you would like to use, and symmetric profile. Okay, the thread 6 degrees or 4 degrees. The depth of this one, make it on the other side, so we can select the face like that, make it offset with 40 millimeters like that. So you can control the element, or you can create it from scratch and add it to your model. You get this point?
Yeah, it's clear. It's clear. No problem.
And this thread series TEMA UN8 thread is available there, the database.
Again, please.
UN8 thread series is available. UN8 TEMA.
So whatever standards is available, whatever database is there with you, so TEMA bolts is also available, right?
Okay, 1 minute, please. Here, those are the available types according to TEMA. Okay, for the front end, shell type, and rear side.
Okay, we got this point. We are asking regarding the bolt only. TEMA bolt.
They are asking, Mr. Ahmed, they are asking regarding the bolt. UNC bolt. TEMA UNC bolt.
UN8 bolts.
During creating our model, we use the UNC bolt.
Yeah.
Are you asking about something else?
Yeah.
Here we select the UNC, or you? I didn't get your point correctly. But here we use the UNC bolt and select the size of the bolt if you would like to make it with the millimeters units or in ANSI units.
Yeah, but this is the question they are asking.
Okay. Okay, if you can figure it here. We use this UNC bolt or stud bolt for the.
Yeah, for the UNC bolt, we normally use till 1 inch. Above 1 inch, we used to follow UN8. Means 8 thread minimum. That's the TEMA standard.
No, that's the standard here or the database here for bolts.
So can we select?
If you would like to add something to SEG library, you could send it to us and send the Excel sheet or the PDF, and our technical team could add it. I will show you something. We prepared it for one of our customers. They asked about it here for the tube sheet. It's not.
Yeah, no, we understood.
To TEMA. If you take a look to this type of tube sheets, they asked us to add this type of tube sheet, which include a groove here and a single raised face for the other side, which is not according to TEMA standard. So they asked us, and we added to SEG library to be able to use it anytime. So if you would like to add something to use it in the future, you could send it to us, and our technical and development team will add it to SEG library. One of our customers, for example, which they are S-Tank, they are from South Korea. They are a manufacturer of storage spherical tanks. So they asked us to add some features to the blade arrangement for spherical tanks, and we generated for them as per their request. Okay, so I hope this point I can make it clear for you right now.
Yeah, and you have done any API coolers as well?
Again, please. Again, please. Hello?
Air cool heat exchanger.
Air cooler?
Yeah.
Okay, so let's open this more.
With the fin tubes actually.
That's an old one.
Okay, what we'll do, we will send our questions to you after that. No worries.
Okay, I will. I want to show you something. It will not take seconds here, please. I thought that you take a look to SEG capabilities before this session, but let's say that again, no problem. Here for SEG software, it is the only existing software can do all of this stuff of equipment. It can generate horizontal and vertical pressure vessels, can be able to generate columns with multi-sectional sections and different diameters and thicknesses, storage tankers with fixed roof, TEMA heat exchanger, equipment piping, slug catcher, ducts, and spherical tanks. No existing software can do all of this stuff under one umbrella, and here no TEMA heat, no air coolers or calculations. Okay, some of our customers during the sessions asked us, is there any calculation, how we can calculate the thickness of the head? Here SEG, it's not a calculation software. Okay, it's for modeling and detailing.
We understood this one. Now we have another mistake. We understood the concept, what we can do, and if the design output is available, we can prepare the drawing within the short time as per whatever you have shown to us. So if we have any queries now, we will send one email within one query and let us know what is available, what is not available, what can be added, what cannot be done. It's fine for us now. Concept is clear, and we are happy with the presentation as well. First of all,
thank you so much for your valuable time, and I hope in this session I could cover some of your queries and questions. And inshallah, if you still have any issues or any questions, kindly contact Deepak to and send him your questions, and inshallah in in the same day or the next day, our technical team will reply on your questions.